Have you ever just stopped for a second and thought about the pure magic that happens when you ask your phone for directions? You just type something in and bam, this little blue dot knows exactly where you are, right down to the meter. It's a miracle we use every single day, and we almost never think twice about it. So let's dive in and pull back the curtain on this incredible, invisible system.
And look, it's so much more than just finding the closest pizza place. This quote really nails it. GPS isn't just an app on your phone. It's a fundamental utility, like electricity or water. It's so deeply baked into everything we do that if it just switched off, the world would pretty much grind to a halt. We're talking total chaos for shipping, aviation, even your bank.
So that brings us to the big question, right? How does this network of satellites, flying thousands of kilometers over our heads, know exactly where your phone is? The answer is just this beautiful mix of really simple geometry and some pretty mind-bending physics.
Okay, so let's start with the basics. We have to get our heads around the geometric principle that makes GPS work, and it's probably not what you think it is. In fact, we need to clear up a super common misconception right from the get-go.
Now, most of us have heard of triangulation, using angles from different points to find a location. But that's not what GPS does. Nope, it uses something called trilateration. The key difference? It's all about measuring distances, not angles. And that single detail is absolutely crucial to how this whole thing works.
All right, let's build this up. Imagine just one satellite in the sky. It sends out a signal and figures out you're, let's say, 20,000 kilometers away from it. Well, that means you could be anywhere on the surface of a giant, imaginary sphere with that satellite right in the center. It's a start, but not very helpful, right? We need to narrow that down a lot.
So let's add a second satellite to the mix. It does the same thing and finds out you're, say, 19,000 kilometers from it. Now, where do those two giant spheres of possibility overlap? They intersect to form a perfect circle. All of a sudden, we've gone from an entire planet's worth of surface area down to a single line. We're getting much, much closer.
And then comes the third satellite. This is the clincher. It creates its own sphere of distance, and when that sphere cuts through the circle we just made, we are left with just two possible points. That's it, from infinite possibilities down to just two.
So how do we pick between those two final points? Well, it's usually pretty easy. One of those points is almost always a ridiculous answer, like it's thousands of miles up in space, or it's moving at 10,000 miles an hour. Your phone's software just instantly discards the impossible one, leaving your precise location. So 3 satellites and we're done. Problem solved, right? Well, almost.
See, here's the secret sauce. The satellites aren't measuring distance with some kind of cosmic tape measure. They're measuring time. The satellite sends a signal with a timestamp, your phone receives it, and by measuring that tiny, tiny delay, it calculates the distance. Why? Because we know the signal travels at the speed of light, which is constant. And this total dependence on time, well, it throws a fascinating wrench in the works.
This is where the whole story takes a really cool twist. We thought we had it all figured out with 3 satellites and some basic geometry, but it turns out there's a hidden variable that we haven't talked about yet.
I mean, it makes perfect sense, right? To find your position in our 3-dimensional world, you need to solve for 3 unknowns: your latitude, your longitude, and your altitude, your x, your y, and your z coordinate. 3 unknowns, 3 satellites. It seems like a perfect, elegant balance.
But there's a 4th phantom variable lurking in the equations. That whole distance calculation, the entire system, hinges on measuring the signal's travel time with perfect accuracy. And for that to work, your clock needs to be perfect too. And guess what? It isn't.
Here's the problem. The atomic clocks on those satellites are absolute masterpieces of precision. We're talking accurate to within a few billionths of a second. The cheap quartz clock in your phone, it's not even in the same universe. Even a tiny, minuscule error in your phone's clock would create a massive error in the distance calculation, making the whole system totally useless. So we now have a 4th unknown we have to solve for, your receiver's clock error.
And what's the basic rule of algebra? If you have an equation with 4 unknowns, you need 4 pieces of information to solve it. You need a 4th measurement. You need a 4th satellite.
And this is the absolute genius of the entire system. That 4th satellite signal gives your phone the extra piece of data it needs to solve for all 4 variables at the exact same time: x, y, z, and the time error. It literally figures out how wrong its own clock is and corrects for it on the fly. It's like getting a free atomic clock in your pocket, synchronized to a global standard. It's just brilliant.
Okay, so we've nailed it down. You need a bare minimum of 4 satellites visible in the sky to get a good, accurate fix on your position. But that leads to the next logical question. If 4 is the magic number, why is the whole system built with so many more?
So let's dig into that. If 4 is all it takes for you, standing in a field, why did the engineers go to the incredible expense and trouble of putting a minimum of 24 satellites into orbit? The answer is all about redundancy and guaranteeing one simple promise.
The solution is this incredible piece of orbital choreography. It's a celestial blueprint. You have these satellites arranged in a precise, elegant dance across 6 different orbital paths, with at least 4 satellites in each one, all orbiting way up there at over 20,000 kilometers. This isn't random. It's a masterpiece of orbital mechanics, and it's all designed for one very specific purpose.
And that purpose is this: to make an ironclad guarantee that no matter where you are on the face of the Earth, from the middle of the ocean to the top of a mountain, day or night, there will always be at least 4 satellites in view, ready to give you a signal. It's a safety net for the entire planet.
So when you put all of these pieces together, you have this silent, invisible chorus of satellites constantly singing the time from orbit. And their perfectly synchronized song has quietly revolutionized our entire world in ways we barely even notice.
For starters, it completely changed global logistics. Every single airplane in the sky, every container ship on the ocean, they all navigate with a level of precision that was pure science fiction just a generation ago. But here's one that might surprise you: banking. The ultra-precise timing signals from the GPS network are used to timestamp and synchronize financial transactions across the entire globe. It's a hidden backbone of the world economy that almost nobody knows about.
And it touches our lives in even more profound ways. It allows farmers to plant crops with centimeter-level accuracy, saving resources and increasing yields. It guides ambulances and firefighters to exactly where they need to be, shaving off precious seconds that can literally save lives.
It really makes you wonder, doesn't it? GPS began as a military project, and over time it evolved into this indispensable public good, this invisible utility that quietly runs the modern world from behind the scenes. And it leaves you with this one final thought. What's next? What other invisible systems are being built right now that will become the silent chorus for the next generation?